Okay, so let's try this again. Take three. It's very early in the morning. Let's get this done. Okay, so this is unit 5, the last unit. Yay! What is this unit going to look like? Well, we're going to be talking about logic and making decisions based on logic. This includes sets, Venn diagrams, truth tables, and biases. So we're going to be looking at all of these things. You're going to have 4 homeworks, 1 quiz, but no exam for this unit. The material from this unit will be covered in a section on the final exam. Okay, and I'll talk about that more later, but let's get started with sets and Venn diagrams. So we're going to do a lot of like vocab crap here to begin with. So let's get started. A set is any collection can make a set. Okay. Any collection can make a set, and a set is a collection of distinct objects of any kind, right? And each of those objects inside that set is called an element. Commonly, we use variables to denote sets. Okay, we'll say set A, set B, set C, things like that, where we've defined what those sets are. This funky little symbol right here. Oops, I'm on erase because I've had to erase everything because this is the third time. Okay, so this little symbol right here, it's like a C with a little line through it. It is an element of, and we're going to be using that notation. All right. Other notation to be noted is that a set is always contained in curly braces. These are curly braces. Not parentheses, okay? If you use parentheses, I'm going to mark you off because we don't use parentheses. I spelt that wrong. Okay, curly braces, not parentheses. But what this line here is saying is a set that has no elements is called an empty set, and it can be denoted by either empty curly braces or a 0 with a slash through it. Those are the two notations that we can use for empty set. Let's keep on. There's lots of information here. So sets can be described or they can be listed explicitly. Okay, and so here's an example of sets that could be defined, like the set of all even numbers, or the set of all the books written by Aleister Crowley, or say a set of all the car make and models in parking lot 3 at East Georgia State College. I mean, we can do anything. We can also list them explicitly. So we can list the elements, and a lot of times it's called explicitly. And explicitly doesn't necessarily mean that it is racy or sexually charged or anything like that. Explicitly means giving you every single element, telling it to you very, very specifically, explicitly in detail. Okay, and so here are 3 examples of some explicit sets. The first set is like the face cards and the ace. Second set, it looks like the powers of 3. And the third set is the colors of the rainbow. All right, now let's look a little bit more on how are we going to work with this notation. So for this example here, we're going to let set A be equal to 1, 2, 3, and 4. And that's what we call this. This is set A. Set A is equal to 1, 2, 3, and 4. And so we can, if we want to notate that 2 is an element of the set, we would write it this way. We'd say 2 is an element of A. All right. Now, if we wanted to notate that 1 and 3 are elements of the set, we would have to write that because that is a little set within a set. So 1 and 3 in curly braces is an element of A. We could also say that 1 and 3 and 2 are subsets of a larger set of 1, 2, 3, and 4, and we would write that as this. 1 and 3 is a subset of A, or 2 is a proper subset of A. These were going to be proper subsets. Remember, a proper subset is any subset that is smaller than the original set. Okay. All right. Let's keep on going here. So let's get a little bit more talking about subsets. So a subset of a set is any set that is made up of the elements of the original set. Okay. Now, there's two types of subsets if we're going to be technical. Of course, we're not proving anything, so we don't have to be that technical, but there is a difference that must be explained. So we have subset, which means that it includes all the elements of the original set, could be less, but could include every same element, could be the exact same set. Okay, so a subset could be the original set. But a proper subset, which is what we're really going to deal with. A proper subset is a subset that's not identical to the original set, but is made up of everything in the original set. So missing a thing or two. In other words, like that last example where we had A was equal to 1, 2, 3, and 4, then 1 and 3 is a proper subset of A, but 1, 2, 3, 4 is a regular subset of A because it includes everything. Okay. It's just getting into some of the details. We won't really do too much with it. We'll be pretty much dealing with proper subsets. Okay. So just as an example here are 3 sets. The first set is described, and it's described because it's not possible for us to write down explicitly all the elements because it's an infinite list, okay? Set B is the elements 2, 4, and 6, and set C is the elements 2, 3, 4, and 6. Set A is described as a set of all even numbers. So we can observe that set B is a subset of A, and it is a proper subset of A because every element of B is also in A, but not every element in B is an element of A. I mean, not every element of A is in B. So they're not equal, they're proper subsets. Okay. It can also be said that B is a subset of A because X is an element of B and X is an element of A. We can say that they're subsets because 2 is an element of B and 2 is an element of A. 4 is an element of B, 4 is an element of A, 6 is an element of B, then 6 is an element of A. That's just some of the information you can get from the fact that it's a subset. Again, we're not going to be proving anything, so don't panic. I'm just trying to give you all this detail here so you understand the language. B is a proper subset of C, but C is not an element of A. Okay, so B could also be a proper subset of another set that is not a subset of the original set. So it can get really sticky here, and we're not going to get that deep in the weeds, just making the point. Okay, the big thing that we're going to talk about, and the thing that's going to translate all the way through this entire unit here, is the idea of intersections, unions, and complements. Okay, so the union of two sets is a set that contains all the elements in either set or both sets. Okay, so all the elements, it's just like a master list of everything contained in both. Okay. And it's yoded, it's noted by a big U. So we would say A union B. Okay. Formally, if we want to use a formal definition, they are unions. X is an element of A union B if X is in A and X is in B or in both of them. So this is more like A or B or both. Okay. The intersection of two sets contains only the elements that are in both sets, and that is indicated by an upside down U. A intersects B, and formally, X is an element of A intersects B is if X is an element of A and X is an element of B. See, I found this typo on here. This needs to be or both. Okay, very good. All right, so let's see what we can do with this. Oh, also the complement, right? There are three things here. There's the union, there's the intersection, and you'll remember complements from when we did probability. Complement of a set contains everything that's not in the set. Now, we did complements in probability with a bar, but here we're going to use this little C, or we're going to start using the tilde A. Okay, so let's look at this first example. Yay, we made it to an example. Oops, darn it. Let me hide that. Okay. Consider the sets. We have set A is red, green, and blue. Set B is red, orange, and yellow. And set C is red, orange, yellow, green, blue, and purple. So the first thing it asks us to find is the union between A and B. That is all the elements in A and B, no repeats. So usually what I do is I'll write down the first one, red, green, blue, and then I'm going to look at the next set. I already have red. I need orange and yellow. So there is our set. Let me erase that off of there. Okay. So A union B, or A intersect B, so that's A union B, red, green, blue, orange, yellow. A intersect B, that's the ones that are the same. Well, it looks like we've got red, green, no, blue, no. Okay, so we just have one element, red. Finally, this one, this is A complement intersects C. So this is kind of complex. We need to first find A complement. So A complement, that is everything that's not in A. Okay. And so red is in A, but orange is not in A. Yellow's not in A. Green's not in A. I mean, green is in A, my bad. Green is an A, blue is an A, purple, not an A. Okay, so now we found that. Now we'll do A complement intersects C. And what in A complement intersect with C? That is going to be orange, yellow, and purple. Okay. So let's get to the next concept. Before we do, let's have our attendance silly phrase for the day. And today's silly phrase is, my lawn chair wrote me a love letter at dawn. I'll give it to you one more time. My lawn chair wrote me a love letter at dawn. Okay? All right. I know you're going to be missing those. All right, let's get on to the idea of universal sets. So that last problem might have been a little bit confusing because you might have been like, well, what are we comparing A to find A complement? And that's where the idea of universal set comes in. And I used set C here as the universal set in this example, but it's not up to you to decide, okay? So moving forward, we'll have an explicit explanation on what the universal set is. So the universal set is a set that contains all the elements that we're interested in. And this could be defined by the context, right? So it could be the universal set, could be all the colors of the rainbow with this previous question that we just had, or we could have a universal set be all the odd numbers or all the even numbers. It just depends on how it's defined. The complements relative to the universal set. That's the only thing that actually makes sense. So we could all do the exact same thing. If not, we're all going to define the universal set differently and we're all going to get different answers. So the universal set is going to be defined. So take a look here. So suppose the universal set is all the whole numbers from 1 to 9. Now that's a pretty small set. I could actually write that out, right? So just for giggles, because I feel silly, but I need a different color pen here. Let's see. So just for giggles here, I could write out our universal set. Here is 1, 2, 3, 4, 5, 6, 7, 8, 9. There it is, explicitly written. And if A is the set 1, 2, and 4, then A complement is going to be all the numbers that are not in A, which are 1, 2, and 4. So this leaves us the complement, 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 complement. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yay. Okay. All right. So let's look at this example here. Now I wrote on top the universal set, and I want to give you a very nice, helpful hint. When you're presented with stuff like this, it is very helpful for you to put each one of those in alphabetical order. Spend a moment, rewrite it, put it in alphabetical order so you can see without driving yourself crazy. So this guy in alphabetical order is going to be cat, dog, mouse, and rabbit. This one, if I write it in alphabetical order, is going to be cow, dog, duck, pig, rabbit. See how that kind of helps line things up a little bit and see where things are. And then here, it's going to be deer, duck, frog, mouse, and rabbit. Okay, now we're going to be doing kind of some complicated stuff. Now, thing that you want to keep in mind when we're doing these set operations, that's what we're doing here. These are set operations. What you want to keep in mind is that parentheses go first. There's order of operations here, and the order is that you must do the stuff in parentheses first. So on this first piece here, we need to find H intersect F. So I'm going to go H intersect F, and let's find H intersect F. So we've got H and F, and it's the intersection. It looks like we've got dog and rabbit. Okay, but the whole thing is that unioned with W, and so that's going to give us, let's see, deer, dog, duck, frog, mouse, rabbit. Deer, dog. Okay, so I got the deer from here, the dog from here, duck, frog, mouse. All those are in there. Duck, frog, mouse, and rabbit. Okay, let's do the next one. The next one is find H intersect with F union W. So let's find F union W. And it looks like we've got cow, deer, dog, duck, cow, deer, dog, duck, deer, dog, duck, frog, mouse, pig, rabbit. And now we want to say H intersect with F union W. So we'll intersect H with this. Cat, no. Dog, no. Deer, no. Yep, dog. So we got dog. Dog and dog. Duck, no. Frog, no. Mouse. Got mouse. Pig, no. Rabbit. Okay. And so let's look at this next one here. Oops. I went too crazy. Let me use my mouse. There we go. And so this final one, we need to find H intersect F first, which we have right here. So that is dog and rabbit. And now we want to find H intersect F complement. And what are we missing from dog and rabbit? Well, we've got cat. We've got cow. We've got deer. We've got the dog here. We've got duck, frog, pig, and mouse. Now we want to do that, and we want to intersect it with W, and let's see what that's going to turn out to be with W. No, let's see, cat. Here's W right here. So cat, cow, W doesn't have any C's, so we do have deer and duck. We got frog. Frog is there. Pig. Pig is not in W, but mouse is in W. And there it is. Okay, tedious. Are you wondering how this is math? It's very much math. Okay, let's keep on going. All right. Now, an effective way to visualize interactions of sets is by using Venn diagrams. And I know you have been introduced to Venn diagrams in your life, okay, coming up to this point, but let's have a reintroduction just so we can see how these go. Now, there's two things that are super important about the Venn diagram. There's the circles, and then there's the square outside. The square outside the circles indicates the universal set, like all of the things, okay? So it's very important that you have that square. I'm going to denote my guys here. This is A and this is B, and I want to show what A union B looks like, and I'm going to show it with shading, okay? So it's all of it. That's that whole thing shaded. Okay, let's do our A and our B here, and let's look at what A intersect B looks like. That's just where it overlaps. This is where everything overlaps. And then this other one is going to be a little bit crazy. I'm going to do A complement intersect C. I don't know where the C came from. Goodness gracious. B. Okay, this being A and this being B. Now, A complement is everything that is not A. So that's all that is A complement. And then here it is, intersected with B. Okay, so all of that is A complement, including over here where my drawing was crappy, but this is intersected with B, so that's the answer. Okay, so let's look at this guy here. Use the Venn diagram to illustrate H intersect F complement intersected with W. Okay, now H intersect F is this right here. That's H intersect F. So if we're talking about the complement, that's everything outside. I'm just going to make some marks here. That is H intersect F complement. All this that I've colored. I hope you understand what I'm doing here. Now we want to intersect it with W. Okay, so we want the complement intersected with W, and that's going to give us, let me think about it for a second. It's going to give us this. It wants to give me a straight line. I don't want a straight line. Let me use the highlighter. It's going to give us this. Okay, so all these little striped red lines are that H intersect F complement. That's everything but H intersect F. Okay, that's all of this. And then we intersected it with W here, and that highlight is the answer. Okay, let's try another one. This one asks us to decide what's happening. Like, what is the representation here? What gets us that yellow place? right there in the middle? Well, we got to kind of break it down a little bit. First, let's look at the idea that J intersect K would be all of this. I would include all of this, right? That would be J intersect K. We don't get this piece here, so that is going to need to be intersected with L complement, everything but L, and that's going to make this little piece right here go away and give us just that one little thing. Now, there's one thing we need to add to this that's very important, and that is this set of parentheses here. So let me write it more clearly. J intersect K intersect L complement. That's what this is. J intersect K intersect L complement. It really helps if you know how to say it, right? Okay. All right. And then I think this is our last one. We're going to create an expression that represents this following Venn diagram. So first off, hopefully you can see that this is Q union R. That's this whole thing would be. So it's Q union R, but then it's intersected with everything but S. Okay. All right. That gets us started. There's not going to be a whole lot of work in the homework. I mean, your first homework assignment is going to go pretty easy on this. It's really a lot of sets and just putting a couple of sets together, a couple of Venn diagrams, but we're going to get into more Venn diagrams in the next section, really doing some work with them. All right. Well, we did it. All right. Have a good day.